Okay, so for each trig function, there are only you're only going to get certain types of numbers. So let's look at sine and its reciprocal first. No matter what you plug in for your angle for this that you're going to take the sine of, you will always get a number between or equal to -1 and through 1. So in between -1 and 1 inclusive. And that goes for any positive or any negative angle theta. Your sine will be between a -1 and 1 inclusive. Never be anything greater than 1. Never be anything smaller than -1. So if you get that, or if you're working on a problem and you see that value is for your sine, then you know it's not possible. You've done something incorrect, or the information is not correct. In terms of its reciprocal function, cosecant, cosecant's going to be less than or equal to -1 or greater than or equal to 1. So where sine has to be in between a -1 and 1, cosecant goes outside those ranges. And it's the less than -1, less than or equal to -1, greater than or equal to 1. Let's see. There we go. Cosine is the same as sine. All cosine values, no matter what the measure of angle theta is, will be between a -1 and 1 inclusive. And then your secant, same as cosecant, it gets the outside values then. Those numbers that are less than or equal to a -1 or greater than or equal to 1. With tangent and cotangent is that they can equal any real number. No restrictions on the y value when we plug in any value for theta on tangent and cotangent. Okay, so we're going to decide whether each of the following statements is going to be possible. Whether our sine or cosine or tangent, cotangent, secant, or cosecant, if it's an allowable value for that trig function. Okay, so our first example is we want to know if it's possible for the sine of theta to equal a -1.1. So what we have to decide is a -1.1 is a -1.1 in between a -1 and +1. No. So we would say not possible. Theta, the sine of theta can never be that value. Okay, the next one, tangent of theta equals 2. Yeah, tangent and cotangent can be any real numbers, and 2 is a real number, so we're going to say that's possible. Probably could just say yes or no on these, and that would be sufficient. And then the next one, cosecant is, that's supposed to be square root of 3. Is it possible for the cosecant to equal the square root of 3? What's the decimal approximation?
It's going to be more than 1.
I want to say 1.7-ish. Okay, so that is greater than 1. So let's go back up here. Cosecant can be, it will be greater than 1, right? So this one is possible. Did you put less than? Oh, gotcha. Okay. Okay, I think that's all of those examples. Okay, so now we're going to go to where we want to find the angles between 0 and 360 that have this value, this trig value. So let's write this down, then we'll talk about what values that work for theta in this equation. Okay, so theta is in between 0 and 360 inclusive, so it could equal 0, could equal 360. And we want to know what angles for theta have a sign that is equal to negative radical 3 over 2. Okay, so let's go, I think it's section 6.2. Section 6.2, do you have a chart that has all the trig values for special angles? Did you put a table in section 6.2 in your notes that identifies where sign? Okay, so we're going to use that. And then we're also going to use what we know about quadrants. Okay, so we have our quadrants 1, 2, 3, and 4. Which quadrant is sign positive in? Everything's positive in quadrant 1. Quadrant 2 is also positive for sign. So we know that our angle has to be in quadrant 3 or 4. Okay, but which angle theta using your chart has a sign of radical 3 over 2? 60. Is that the only one? Okay, sine. So we know we have this angle, that could be 60 degrees, right? And this angle, that could be 60 degrees. And both of those would have a sign that's negative.
Quadrant 3 would be negative.
Quadrant 3 is negative?
It would. It wouldn't be. Because it's 2 negative. Oh, wait, no.
But we're doing sine.
Yeah, hypothesis.
Okay? Everybody okay with that? Agreeing that in quadrant 3 and quadrant 4, we have angles with a sign that is negative. And in order for it to be a negative radical 3 over 2, its reference angle has to be 60 degrees because the sign of a 60-degree angle is radical 3 over 2 using your chart. So, what is this angle measure then?
That is 240.
180 plus 60 is 240 degrees. So that's that angle. And then what is this angle measure?
Wait, it's yeah,
It's 300 exactly because it takes another 60 to get to 360. So the two angles for theta that would give us a sign of negative radical 3 over 2 that are between 0 and 360 are 240 degrees and 300 degrees. Okay, so let's process that again. The first thing we did was we identified which quadrants the sine function had a negative value in. And we determined it was quadrant 3 and 4. Then we looked on our chart from section 6.2 to see which angle has a sine that is equal to 60 degrees. I mean, a sine that is radical 3 over 2. And that's a 60-degree angle, has that sine value. So in quadrants 3 and 4, I had to draw a 60, 30, 90 triangle. And then I figured out what angles had a terminal side for those two triangles that I drew. Clear as mud? Let's do another one. So we said, using our chart from section 6.2, that at 30-degree angles, cosine was radical 3 over 2. We have to take into consideration this negative right there. And we have to figure which quadrants we're looking at for angles that have a negative cosine. So first quadrant, everything's positive, right? And what other quadrant is the cosine positive in? Fourth. So we're looking at angles in the second and third quadrant. So we need to draw a triangle in each one of those. Let's just do the second quadrant to begin with. And we know this angle, our reference angle is 30 degrees, so that's this angle right here. That's 30. So we're finding out what does this angle measure have to be in order for us to have a reference angle for 30 degrees. We take 180 would be all the way to the axis, right? So 150 degrees will have a terminal side right here, giving us a reference angle of 30 degrees. And because it's quadrant 2, the cosine of that would be negative radical 3 over 2. So then the third quadrant also has a negative cosine, correct? So the reference angle, for this to have a 30-degree angle, we would have to draw that right triangle. And because we're told that theta has to be between 0 and 360, we have to use the positive values. So we're going to start here, and our terminal side has to be there. So rather than subtracting 30, we're going to add 30, right? To give us 210 degrees. So the two values for theta in quadrants 2 and 3, that would give us a negative radical 3 over 2 for the cosine, would be 150 degrees and 210 degrees. Section 6.2, the sign, where the sign is a half. Where is that? 30 degrees? Okay. So we know our reference angle for our triangle is going to be 30 degrees. Okay, and we said sine is positive in quadrant 1 and quadrant 2. So we're looking at quadrant 3 and quadrant 4. So my reference angle for quadrant 3 would be right here. And I would draw the angle that ends there. And how do we figure that measure? 180 plus 30, which is 210. And then the fourth quadrant reference angle 30 has to go here, meaning here's my right triangle. And I have to start here, and my terminal side has to end there. 360 minus 30, 330. So theta is either 210 degrees or 330. Remember, we're always going from the x-axis to help us figure those measures. Okay, for tomorrow, I want you to just do one of these and put it in your notes. So